What specific problem does this paper aim to solve regarding the causal reasoning of LLMs and humans?
This paper aims to investigate and compare the causal reasoning abilities of large language models, LLMs, and humans, specifically focusing on biases in causal inference. It addresses the concern that LLMs may rely on learned patterns rather than genuine causal relationships, which raises questions about their robustness in high-stakes scenarios. By utilizing a collider graph structure, C_1 right arrow E, left arrow C_2, the study evaluates how both LLMs and humans make inferences based on causal relationships, examining whether LLMs exhibit similar biases to those observed in human reasoning. The research utilizes the Clatter dataset to assess the formal causal reasoning capabilities of LLMs and compares their performance against human judgments, thereby contributing to the understanding of how LLMs reason causally and whether they align with normative principles of causal reasoning. Ultimately, the paper seeks to clarify the extent to which LLMs can generalize causal ideas and whether their inferences reflect the domain knowledge embedded in their training data.
Can you explain how the proposed method of comparing causal reasoning between LLMs and humans works? Illustrate the methodology step by step.
The proposed method for comparing causal reasoning between LLMs and humans involves several key steps. First, the researchers utilized a causal inference task dataset that replicates the experimental conditions of previous human studies, specifically focusing on a collider causal structure, C_1 right arrow E, left arrow C_2. Participants, both human and LLMs, were presented with domain-specific narratives and asked to provide likelihood judgments on a continuous scale, 0 to 100, regarding causal relationships based on given observations. The LLMs were prompted with the same inference tasks as humans, but their responses were generated in a single numeric format, ensuring consistency. Next, the researchers computed Spearman correlations between the inferences of LLMs and humans to assess the degree of alignment in their reasoning patterns. Finally, they fitted causal Bayes nets, CBNs, to the judgments of both groups, allowing for a comparison of how well each group's responses matched normative causal reasoning principles, revealing insights into the influence of domain knowledge on LLMs versus human reasoning. This comprehensive approach enables a detailed analysis of biases and reasoning similarities between LLMs and human participants.
Can you provide a simple example that explains how one of the inference tasks in the study operates, specifically in the context of the $C_1 right arrow E, left arrow C_2 collider graph?
In the context of the C_1 right arrow E, left arrow C_2 collider graph, consider the inference task where we observe low socioeconomic mobility, E, and low urbanization, C1. The task asks how likely it is that low interest in religion, C2, is true given these observations. According to the causal mechanism, high urbanization, C1, and low interest in religion, C2, both influence socioeconomic mobility, E. When both C1 and C2 are absent, the inference task requires reasoning about the likelihood of C2 based on the observed state of E. The expected reasoning pattern would involve explaining a way where observing low socioeconomic mobility, E, would decrease the likelihood of low interest in religion, C2, as both causes are needed to produce the effect. This task illustrates how the collider structure influences causal reasoning, as the presence of one cause, C1, should lower the probability of the other cause, C2, when the effect E is present.
What theoretical or practical benefits does this research present in understanding the causal reasoning of LLMs compared to human reasoning?
This research provides significant theoretical benefits by establishing a comparative framework for understanding causal reasoning in LLMs versus humans, particularly through the use of causal Bayes nets, CBNs, as a normative benchmark. By analyzing the biases and reasoning patterns exhibited by both LLMs and humans in causal inference tasks, the study reveals that while LLMs demonstrate a degree of human-like performance, they also exhibit systematic deviations, such as stronger reliance on domain knowledge and deterministic interpretations of causal relationships. Practically, this understanding is crucial for deploying AI systems in high-stakes scenarios, as it highlights the limitations of LLMs in generalizing causal ideas beyond their training data. The findings suggest that LLMs may not always align with human reasoning, particularly in complex causal contexts, which is vital for applications in fields like healthcare and policymaking. Overall, the research underscores the importance of evaluating ILM's causal reasoning capabilities to ensure their reliability and effectiveness in real-world applications.
How was the method validated, and what datasets were used to compare the causal reasoning of LLMs and humans?
The method was validated by comparing causal reasoning judgments from humans and 4 LLMs, GPT-3, 5 GPT-4o, Claude 3 Opus, and Gemini Pro, using a causal inference task dataset designed to replicate experimental conditions from previous studies. The dataset included a collider causal structure, C_1 right arrow E, left arrow C_2, embedded in 3 different knowledge domains, meteorology, economics, and sociology, allowing for a natural language description of the causal relationships. Human participants provided likelihood judgments on a continuous scale, while LLMs were prompted with the same inference tasks and instructed to provide numeric responses. The performance of LLMs was assessed through Spearman correlation with human judgments, revealing substantial positive correlations, particularly for Claude and GPT-4o. Additionally, causal Bayes nets, CBNs, were fitted to both human and LLM responses to evaluate the alignment of their inferences with normative causal reasoning principles, further validating the method.
What significant results were achieved, particularly with respect to the performance of different LLMs in relation to human reasoning patterns?
The study found that the performance of different LLMs exhibited substantial correlations with human reasoning patterns in causal inference tasks, with Claude 3 Opus and GPT-4o showing the highest average correlations, R_S equals 631 and 0.626 respectively. While LLMs demonstrated a degree of human-like performance, they also displayed notable deviations, particularly in their treatment of causal relations as deterministic, which was more pronounced in GPT-4o. The LLMs, especially GPT-4o and Claude, were better fit by a causal Bayes net model that allowed for different strengths of causal relations, indicating they utilized domain knowledge more than human subjects who did not benefit from this extra parameter. Additionally, the LLMs exhibited a broader range of responses compared to humans, suggesting they were influenced by their training data's domain knowledge. Overall, while LLMs captured core causal reasoning principles, their reasoning patterns revealed a reliance on learned associations rather than purely normative reasoning.